All right, 8-6 in geometry. A lot of practical problems today where we have to think ourselves through the jam. They ask us what will be the weight of an open-topped hemisphere. That just means it's half of a sphere in this case. It's a steel tank with a radius of 9 feet when it's full of water. So that means I want to find the volume of that dude. But they also, since it's made of steel, like that steel has some weight, so we'll have to add that in also. And that's like the surface area. So we got to do like 2 for 1 here. So we're going to find the volume of the sphere. But remember, this is going to be the entire sphere. We only have a hemisphere. So we can end up like dividing this by 2 once we find the volume of that guy. So 4/3 pi r cubed, Mr. Fawnensteel, is the formula on that guy. So we'll just kind of sub them in like so. 4/3 times pi. The radius is 9. And we are in good shape because even though that's in feet, all of these conversion rates are also dealing with some sort of feet, even though they're like cubic feet or square feet. So we don't have to do any converting. So if I punch that in, looks like this: 4/3 times pi times 9 to the third, 3053.6 is the volume of the entire sphere, like approximately 3053.6. But what we want to do is we want to divide that by 2 because that's the entire sphere, and I just need half of it, so divided by 2. And about 1526.8. So the volume of the hemi is about whatever I just said, 1526.8. And that's in square feet, cubic feet. The thing is, we don't care about that. They care about how much the water weighs. So since there's this many cubic feet and water weighs this much per cubic foot, we'll take this bad boy times 62.4 and see how heavy this is. So times 62.4. You notice I haven't rounded anything off yet, even though I did it on paper. I didn't do it here. So holy cow, is that heavy? About 95,623 pounds. So about 95,273. And I do know that this says round to the nearest 100 pounds. We're going to wait until we find all of these things together. So I'm just rounding this off right now just to the nearest whole number. So the water weight was about 95,000 some odd pounds. Then the steel weight, that is just the hemisphere itself. So it's like that's the surface area. We'll find the surface area of the entire sphere, and then we will divide it by 2. So 4 times pi times 9 squared in that case. And that number right there, about 1,017.9. See, I'm not even close to done because I got to divide him by 2 because that's the entire sphere, and I want hemisphere, so about 508.9 surface area of the hemi. About, like I said, 508.9 square feet. But we want the weight of that steel, and it weighs 44 pounds per square foot, so we'll take that times 44. And you can see I still haven't rounded anything in this particular set of work. This is what I can round a little bit, you know, it's like, because they want us to round to the nearest 100 pounds. We're going to just round this off to the nearest pound, 22,393, 22,393 pounds. And then the full tank, since they say round to the nearest 100, we'll take these numbers, 22,393 plus 95,273, and add them together. And that's the guy that we want to round to the nearest 100 in this case. So what that means is, if we kind of snip this out so I can write on it, that if they want us to round to the nearest 100 pounds, so that would be this guy right here, because there's ones, tens, then hundreds. I have to look to this pink guy right here to see if he's 5 or larger, which he is. So about 117,700 pounds approximately is what the answer to that bad boy would be. That's pretty heavy, but that's a big steel tank, man. It's 9 feet across, you know, which that's just as a radius. So it's really 18 feet across. That's huge. So another cool question is this septic tank. You can see it's got this shape where it's got this cylinder on the middle of it, and then it's got two like hemispheres on the edge. You got this green one and this blue one. Well, when you put those together, baby, like that's just one total sphere right there. So we really have a cylinder and a sphere, because there's two halves of a sphere that make one. It says, how many gallons does this septic tank hold? Well, that's volume again in this case. So let me erase all this, and we'll find the volume of the cylinder. It doesn't really matter which way you're going to do it, what order. So volume of the cylinder is base area times height. I'm going to change it to pi r squared times h. Let's check our rates here. We are dealing with a rate in basically feet in this case. So this dude is in feet and inches, so 5 foot 9 inches. I need to change that 9 inches into feet. So since there are 12 inches in a foot, I'm going to divide, and like 9 inches is like 0.75 feet. So this would be best for us if we wrote this as 5.75 feet. There was 5 entire feet plus 0.75 feet with that. And then for this guy right here, he is really 3.5 feet, because 6 inches is a half of a foot. It's like 6 divided by 12 is what I'm trying to type in that case. So that's why that's 3.5 feet. The crazy thing is that's the diameter of this guy. I care about the radius. So the radius is half of that 3.5. So if I take 3.5 and divide him by 2, I get 1.75 back on that for a radius in feet. So if I do the volume of my cylinder, it will be pi times the radius of 1.75 squared times the height of the cylinder. That's this guy. He's just like laying down, you know, but that's still the height of 5.75 on that guy. So we go punch all that in. Pi times 1.75 squared times, that the right there was 1.25. Nope, I correct myself. It was 1.75. So then times the height of 5.75. Sorry for the confusion there. But I got about 55.3 for the volume of that entire cylinder. So about 55.3 cubic feet. The problem is that was only this. There's also the sphere part of that guy, right? So remember there's two hemispheres, so I just need the volume of an entire sphere, which is 4/3 pi r cubed. And that would be 4/3 times pi times the radius is 1.75, and then that's got to get cubed. So we will do that, and that would be 4/3 in parentheses times pi times 1.75 to the third in that case, and about 22.4 for that volume, about 22.4. We can add those up, right? And it's cool that we're using the rounded numbers now. It's fine. 55.3 plus 22.4. So the volume of the total is about 77.7 cubic feet. Well, they didn't ask that. They asked how many gallons this holds. So we need to take that times the 7.48. So times 7.48. And this bad boy holds about 581 gallons or 582. I would accept either one because like real life rules say round it up and math rules say round it down. So I'm going to say about 582 gallons because it's a little bit more than 581. So that was the volume of that guy. And then the last one, because we're cutting this worksheet in half, is a globe, which is old school, but the globe is like a sphere. He's got a 16-centimeter radius. It just fits into a cube-shaped box. The rest of the box is filled with packing material. What is the volume of the packing material? So what I like to do is draw a picture of this, but there's no way I want to draw that picture in 3D of drawing a sphere inside of a cube. So I'm going to draw the square shape, which is shape 12 on there, and then find a circle on my geometer that just barely fits inside of it. I know it's not perfect in that case, but here's why I want to draw this picture is because they say the globe has a radius of 16 centimeters, which that's pretty obvious. But what a lot of people don't see, unless there is a picture going on right there, is how long this cube's side length is, because it's not 16. It's got to be twice as long, which is 32, due to that being the diameter of this guy. And truth be told, we all know it's going to be a little bit bigger than 32, so that globe could fit inside, but whatever. They say, what's the volume of the packing material? Well, that's all of this. Like, you know, when they give you an Amazon package, it's full of like all the paper or styrofoam things or whatever, this packing material. So what we'll do is we'll find the volume of the cube, which is just going to be side cubed. So that's 32 is the side length, and we cube him. So 32 to the third. That's a big number, 32,768. That's the volume of the cube in centimeters cubed. And find then the volume of the globe, you know, which is a sphere. So that's going to be 4/3 pi r cubed. So 4/3 times pi times the radius of 16 cubed. And that should be less, right, because the globe fits inside of it. So 4/3 pi times 16 to the third. And that's this number, which I'll round to one decimal place, about 17,157.3. And then they say, what's the volume of the packing material? Well, that's where I'd have to subtract that. The globe take away, or excuse me, the cube take away the globe is everything that's left over. So the volume of the pack is going to be 32,768. Take away that previous answer right there. And they say round that to the nearest centimeter, so, excuse me, cubic centimeter, so about 15,611. About 15,611 centimeters cubed in that case. So how I got that was subtracting to show the work. And there you go. So all we did for homework is just like 1 through 3 on the worksheet, but people had really good questions on the first one on homework, like number 1 here. Like, they're going to paint this guy. They figured out that they're going to have to need the surface area of a cylinder and the surface area of a hemisphere, right, to paint this guy. But what they asked good questions on is like, well, how tall is the cylinder? Because this entire length right here is 38 feet. Check out this radius. How do you feel that that radius is 9 feet, right? Which means that would be the same thing right here. That is also 9 feet. But since this is like half of a sphere, the radius goes everywhere, right? So this distance right here is also 9 feet. So to find the height of the cylinder, you have to take the entire height of 38 and take away 9 from that. So that was a really good question. But we just did the first 3 questions on this for homework. They were kind of tough, so if you had questions, that's normal. Come on in and ask. Have a good one.